Hello everyone. Today we are going to discuss about the test of significance for large samples. That is, the large samples we find the test of significance for using some formulas. First we know about the large sample. That is, sample size must be greater than 30. The test of significance used for problems of large samples are different from those used in the case of small samples, as the assumptions used in both cases are different. That is, the sample size, the small sample size and the large sample size test of significance are very different. The following assumptions are made for problems dealing with the large samples. The first one is almost all the sampling distributions follow normal asymptotically. That is, the sample size must be larger and the distribution estimator approaches to normal distribution. The sample values are approximately close to the proportion values. That means the standard error must be approximately 0. The following tests are discussed in this video. Test of significance for proportion, test of significance for difference between two proportions, test of significance for mean, test of significance for difference between two means. The first one is test of significance for proportion. So test procedure is, first we set the null hypothesis and alternative hypothesis. That is, the null hypothesis is the given proportion is true. The alternative hypothesis is the given proportion is not equal. That means which may be less than the proportion or greater than the proportion. In these test of significance, we take the level of significance value may be 5% or 1%. So in this test, the formula is Z0 is given. So the expected value ZC is also given, that is equal to 1.96 for alpha equal to 5%, 2.58 for alpha equal to 1%. So finally we get the conclusion, that is Z0 is less than or equal to ZC means we accept the null hypothesis. The found value Z0 is greater than ZE means we reject our null hypothesis. So for example, in a random sample of 400 persons from a large population, 120 are female. Then it said that males and female are in the ratio 5.3 in the population. Use 1% level of significance. So here the sample size is 400 and the female, that is number of female sample is 120. P is the observed proportion that is founded by that is equal to 120 by 400, which is equal to 0.30. So first we set the null hypothesis, that is the given proportion is true. That means the males and females are in the females in the population are in the ratio 5:3. So here the given female samples are given. So we calculate the proportion of female in the population, which is equal to 3/8, which is equal to 0.375. The alternative hypothesis is the given proportion is not true. That is, the males and females in the population are not in the ratio 5:3. So here given alpha value is 1%, that is 0.01. So calculation used the given values, we find out the value of Z0 and we get the value of ZE equal to 2.58. So final conclusion, here the values Z0 is greater than ZE. So we reject the hypothesis, that is the male and female population are not in the ratio 5:3. Next one, test of significance for difference between two proportions. So in this case, the given two proportions are given. So we set the null hypothesis that the given proportions are equal. The alternative hypothesis is the given two proportions are not equal. Here also we take the level of significance may be 0.05 or 0.1. Is it not zero? Formula is equal to given. Similarly, ZC equal to given. So final conclusion, here also Z0 is less than or equal to ZC. We accept our null hypothesis. Suppose Z0 is greater than ZC, ZE, we reject the null hypothesis. For example, in certain city 125 men in a sample of 500. So here given two sample sizes are given. The first city is the first proportion, second city is the second proportion. So first sample size is 500, second one is 1000. So here we consider the self-employed persons, right? So in the first city x1 equal to 125, second city 37. So they asked, does this indicate there is a greater population of self-employed in the second city than the first? That means the second city self-employed persons is greater than the first city. We compute this, used this test of significance. So first we set the null hypothesis. That means the two proportions, the given two proportions are same. That means there is no significance difference between the self-employment of these two cities. The alternative hypothesis is here given the second city is greater than the first one. So we set this P1 is less than P2. Here we take the alpha value which is equal to 0.05. So first we calculated Z0, next we calculated ZE. So compare the two values, we get Z0 is greater than ZE. So we reject our null hypothesis at 5% level. So that means there is a significance difference between the two proportions. There is a significance difference between the two given proportions. Next one is test of significance for mean. So the formula is Z not equal to, the formula is given, ZE formula is given. So here the null hypothesis is the given mean is equal to the original mean. The alternative hypothesis, the two means are not equal. Here also we take the level of significance which is equal to maybe 0.05 or 0.01. So final conclusion, the value Z0 is less than or equal to ZE means we accept our null hypothesis. Z0 is greater than ZE means we reject our null hypothesis. For example, the mean lifetime of 100 fluorescent light bulbs produced by a company to be 1570. That means x bar equal to 1570, mu equal to 1500. So S equal to 120 hours, N equal to 100. So we substitute all these values in Z0. First we set the null hypothesis that is mu equal to 1600. There is no significance difference between the sample mean and the population mean. The alternative is mu is not equal to 1600. Here we take the value of level of significance alpha equal to 0.05. We substitute all the values, we get Z0 equal to 2.5 and the expected value ZE equal to 1.96. Compare the two values, we get Z0 is strictly greater than ZE. So we reject our null hypothesis at 5% level of significance. That is the significance difference between the sample mean and the population mean. So in this video, we discussed the test of significance for large samples. We may apply in our real life problems using any of these tests. Thank you. We shall meet in the next video.